Now, in this lecture, we will find the value of DE. In the drawing, we have triangle ABC. We know that CA equals to 2 units. We also know that BC equals to 8 units. And we know that line segment DE is parallel to AB, and we also know that point G is the centroid of triangle ABC. Again, point G is the centroid of triangle ABC. The centroid of any triangle is a point where the three medians intersect. Okay? And we know that line segment DE belongs to the natural numbers, that is to say, the length of DE, of the size of DE, is a number that is natural number. And we want to find out the size of DE, or the value of DE. Okay, so first of all, we have a rule, I will call it rule number 1, that relates to the centroid of a triangle. So according to rule number 1, I repeat again, the centroid of any triangle is the point where the three medians of the triangle intersect. Okay, so the rule number 1 that relates to the centroid states that the centroid of a triangle divides the median in a ratio that in 2-to-1 ratio, or in a ratio that equals to 2-to-1. I will read again the rule number 1 that relates to the centroid. Again, the centroid of any triangle is the point where the three medians of the triangle intersect. Okay, the rule number 1 states that the centroid of a triangle divides the median in a ratio that equals to 2-to-1. Actually, if we have triangle ABC, that could be any triangle, triangle ABC could be any triangle, and we know that AD is the median of triangle ABC. Actually, AD, the median AD bisects BC, or the median AD divides BC to two equal parts. That is to say, BD equals to DC, okay? We know that the median BD divides BC into equal parts. That is to say, BD equals to DC. And we also know that point G is the centroid of triangle ABC. Again, this point G is the centroid of triangle ABC. Then, according to rule number 1, the centroid G divides AD in a ratio that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Okay, again, if AG equals to 2 units, then GD will be equal to 1 unit. According to rule number 1, the centroid G divides the median AG in a ratio that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit, or in other words, AG is twice as large as GD. That is to say, AG equals to 2 times GD. AG equals 2 times GD. According to rule number 1, AG equals 2 times GD. Okay? So, we actually can implement rule number 1 in our drawing, because in our drawing we know that point G is the centroid of triangle ABC. Again, point G, according to what is given us in the question, is the centroid of triangle ABC. Therefore, according to rule number 1, the centroid G divides the median CF in a ratio that equals to 2 to 1. Okay, so if CG equals to 2 units, then GF will be equal to 1 unit. Okay, or we can also say that CG is twice as large as GF. That is to say, CG equals 2 times GF. According to rule number 1, in our drawing, the centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit. So CG is 2 times GF. CG equals to 2 times GF according to rule number 1. Okay. CG equals 2 times GF. So, according to rule number 1, so if we define CG as 2x, that is to say, if CG equals to 2x according to our definition, then we actually can substitute the CG in this equality by 2x, because CG equals to 2x, so we will substitute CG by 2x in this equality, and we'll get that 2x equals to 2 times GF. Then we will divide this equality by 2, and we will get that GF equals to x. So we actually found out that if CG equals to 2x, then GF will be equal to x. Okay, so again we found out that if CG equals to 2x, then GF will be equal to x. Okay, so actually we have another rule, rule number 2. Rule number 2 relates to any triangle. It is true in any triangle. Rule 2. So, in any triangle, so if we have triangle ABC that could be any triangle, again, triangle ABC could be any triangle, and we know that DE is parallel to BC. Okay, if in triangle ABC that could be any triangle, we know that DE is parallel to BC. Then, according to rule number 2, the following relationship exists between the sides of triangle ABC. AD over DB will be equal to AE over EC. Again, if in triangle ABC this could be any triangle, we know that DE is parallel to BC, then the following equality is true, that AD over DB equals to AE over EC. Again, if in triangle ABC we know that DE is parallel to BC, then AD over DB will be equal to AE over EC. Okay? So we actually can implement rule number 2 in our drawing, because we know that in our drawing DE is parallel to BC. It is given us in the question that DE is parallel to BC. DE is parallel to AB. DE is parallel to AB according to what is given us in the question. So if we will relate to the green triangle, triangle ACF, in the green triangle, triangle ACF, Again, in the green triangle ACF, because of the fact that DE is parallel to AB, so according to rule number 2, in the green triangle, CD over DA will be equal to CG over GF. Again, if we relate to the green triangle ACF, we know that in this green triangle, DE is parallel to AB. Therefore, according to rule number 2, CD over DA will be equal to CG over GF. Again, in the green triangle ACF, we know that DE is parallel to BC. Therefore, according to rule number 2, CD over DA will be equal to CG over GF. But what is the value of CG? The value of CG is 2x. And what is the value of GF? The value of GF is x. So in total we got that CD over DA equals to 2x over x. 2x over x is 2 because x over x is 1, so x will get cancelled and we will be left only with 2. So we actually got that CD over DA equals to 2. And if we multiply this equality by DA, we will get that CD equals to 2 times DA. CD equals to 2 times DA. So CD is twice as large as DA. CD is twice, according to this equality, CD is twice as large as DA. So if we define CD as 2y, that is to say CD equals to 2y according to our definition, then we can substitute the value of CD by 2y because CD equals to 2y. We will substitute the value of CD by 2y and we will get that 2y equals to 2 times DA. Okay, here we will divide this equality by 2 and we will get that DA equals to y. We actually found out that if CD equals to 2y, then DA will be equal to y. Okay, so if CD equals to 2y, then DA will be equal to y. Okay? So I will present you a third rule. The third rule states that corresponding angles between parallel lines are equal to each other. again corresponding angles between parallel lines are equal to each other. So I will read rule number 3 again. Rule number 3 states that corresponding angles between parallel lines are equal to each other. So we actually can implement rule number 3 in our drawing, because in our drawing we know that DE is parallel to AB. It is given us in the question that DE is parallel to AB. Therefore, according to rule number 3, because of the fact that DE is parallel to AB, then those two corresponding angles will be equal to each other. Why? Because those two corresponding angles are located between parallel lines. Therefore, according to rule number 3, they are equal to each other. So if angle BAC equals to alpha, then angle CDE will be also equal to alpha. Again, according to rule number 3, corresponding angles between parallel lines are equal to each other. We know that line DE is parallel to line AB, therefore those two corresponding angles that are located between parallel lines will be equal to each other. So if angle CAB equals to alpha, then angle CDE will be also equal to alpha. So I will write it down. Angle CDE is equal to angle CAB, and both those two angles are equal to alpha. That is according to rule number 3. Okay, angle CDE is equal to angle CAB, and those two angles are both equal to alpha. According to rule number 3, that states that those two corresponding angles that are located between parallel lines are equal to each other. And the same thing is true in the other side of triangle ABC. We know that line DE is parallel to AB. Because of the fact that DE is parallel to AB, then those two corresponding angles that are located between the parallel lines DE and AB will be equal to each other. That is to say, if angle ABC equals to beta, then angle DEC will be also equal to beta, because of the fact that those two angles are equal to each other. Again, those two angles that are actually corresponding angles, and they are located between parallel lines. They are located between the parallel lines DE and AB, therefore they are equal to each other according to rule 3. So I write it down. Angle CBA is equal to angle CED, and both those two angles are equal to beta according to our definition. So those two angles are equal to each other according to rule 3. Okay, again, angle CBA is equal to angle CED, and both those two angles are equal to beta. This is according to rule number 3. So we actually found out that those two angles are equal to each other according to rule number 3, and those two angles are also equal to each other according to rule number 3 because they are located between parallel lines. Okay, so we actually have another rule, rule number 4. So first of all, we will focus on triangle, the big triangle, triangle ABC, and the small triangle, triangle CDE. We actually will prove that those two triangles are similar to each other. Okay, again, we will focus on the big triangle, triangle ABC. And on the small triangle, triangle CDE. Triangle CDE. We will prove that those two triangles are similar to each other. Okay? Again, we will focus on triangles ABC and triangle CDE. So we know that angle CAB, angle CAB is equal to angle CDE, and both those two angles are equal to alpha. This is actually according to rule number 3 that states that corresponding angles between parallel lines are equal to each other. So angle CAB in triangle ABC is equal to angle CDE in triangle CDE, and they are both equal to alpha. And we also know that those two angles are equal to each other. So angle ABC in triangle ABC is equal to angle CED in triangle CDE, and both those two angles are equal to beta. Okay. Angle ABC in triangle ABC is equal to angle CED in triangle CDE, and both those two angles are equal to beta. That is actually according to rule number 3. And we also know that this angle, angle C, is a common angle. It belongs to both triangles, to triangle ABC and also to triangle CDE. So we can write down that angle C equals to angle C. That is actually common angle because it belongs to both triangles, to triangle ABC and to triangle CDE. Okay, angle C equals to angle C, it is a common angle. So we actually proved that the three angles of triangle ABC are equal to three angles of triangle CDE. Therefore, we actually proved that triangle ABC is similar to triangle CDE according to angle similarity rule. So I will write it down. We actually proved that triangle ABC is similar, that is the sign of similar, to triangle CDE according to angle similarity rule. Triangle ABC is similar to triangle CDE according to angle similarity rule. So what is angle similarity rule? If you prove that three angles of one triangle are equal to three angles of another triangle, then you actually prove that those two triangles are similar to each other according to angle similarity rule. Okay, so because of the fact that the triangle ABC is similar to triangle CDE, we can conclude that CD over CA is equal to DE over AB. I will repeat again, because of the fact that we proved the triangle ABC is similar to triangle CDE, the following relationship exists between the sides of those two similar triangles. CD over CA equals to DE over AB. Okay? But what is the value of CD? The value of CD is actually 2y, and what is the value of CA? The value of CA is actually CD plus DA. CD plus DA is 2y plus y. So in total we got that 2y over 2y plus y equals to DE over AB, or 2y over 3y equals to DE over AB. So here we have y over y is 1, so y will get cancelled. And what is left after we cancelled y? DE over AB equals to 2 over 3. DE over AB equals to 2 over 3. So here we will multiply this equality by AB, and we will get that DE is equal to 2/3 AB. Okay, we found out that DE equals to 2/3 AB. Okay, so in the next step I will present you a new rule number 4. Actually, rule number 4 states that the sum of two sides of any triangle the sum of two sides of any triangle is always greater than the length of the third side the first part of rule number 4 is that the sum of two sides of any triangle is always greater than the length of the third side. And the second part of rule number 4 is that the difference of two sides of any triangle is always smaller than the length of the third side. I will read rule number 3 again. Rule number 3 states that the sum of two sides of any triangle is always greater than the length of the third side. And the second part of rule number 4 is that the difference of two sides of any triangle is always smaller than the length of the third side. Okay, so I will explain the rule number 4. Actually, if we have triangle ABC that could be any triangle, so this triangle ABC could be any triangle, and we know that the size of side AB of triangle ABC is A units, and the size of side AC of triangle ABC is B units, and the size of side BC of triangle ABC is C units, then according to rule number 4, the sum of two sides of the triangle, that is to say A plus B will be greater than C, that is the third side. So the sum of two sides of the triangle, that is to say A plus B, will be greater than the third side, that is to say will be greater than C. That is the first part of rule number 4. And the second part of rule number 4 states that the difference between two sides of any triangle is always smaller than the length of the third side. So the difference of two sides of triangle ABC is A minus B. A minus B will be always smaller than the length of the third side, that is to say will be always smaller than C, or the absolute value of A minus B will be always smaller than the length of the third side, that is to say will be always smaller than C. Okay, so that is actually the meaning of rule number 4 in terms of equations. Rule number 4 in terms of equations states that C will be always smaller than A plus B, and C will be always greater than the absolute value of A minus B. Okay, that is the meaning of rule number 4. Okay, so now we will implement rule number 4 in our triangle ABC, the big triangle. If we relate to side AB of triangle ABC, we can say that according to rule number 4, AB will be always smaller than CA plus CB from one side, but AB will be greater than the difference between CA and CB, or the absolute value of the difference between CA and CB. Okay, so actually this inequality is the implementation of rule 4, or rule number 4, in our triangle ABC. According to rule number 4, the size of AB in triangle ABC, it is smaller than the sum of the two other sides, that is CA plus CB, and from one side, but from the other side, the size of AB will be greater than the difference between the two other sides, CA minus CB, or the absolute value of the difference between CA minus CB. And what is the absolute value of any number? The absolute value of any number is the distance of that number from 0. Okay? So we know that CA or AC equals to 2 units, and we know that CB or BC, it is the same, equals to 8 units. So AB will be always smaller than CA, that is 2, and CB, that is 8, and it will be always greater than the difference between those two sides. CA is 2 and CB is 8, or the absolute value of the difference between the two sides. AB is smaller than 2 plus 8 is 10, and it is greater than 2 minus 8 is minus 6, and the absolute value of minus 6 is the distance of the number minus 6 from 0. The distance of number minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6. So we got that AB is greater than 6 and it is smaller than 10. So we got this inequality. But we have already found out that DE equals to 2/3 AB. Here we found that DE equals to 2/3 AB. Okay, so we will multiply this inequality by 2/3, and we will get that 2/3 AB is smaller than 2/3 times 10, and it is greater than 2/3 times 6. Okay, and so 2/3 AB is smaller than 2 times 10 is 20, and 20 over 3 is 6.66. And 2 times 6 is 12, and 12 over 3 is 4. So we got that two times 2/3 AB is greater than 4, and it is smaller than 6.66. But what is 2/3 AB? 2/3 AB equals to DE according to this equality. So we can substitute 2/3 AB by DE because it is equal to DE. Okay? And we will get that DE is greater than 4 and it is smaller than 6.66. So we got this inequality. But we also know that DE belongs to the natural numbers. DE belongs to the natural numbers according to what is given us the question. DE belongs to the natural number, that is to say, DE or the size of DE is a natural number. DE belongs to natural numbers. So which natural numbers we have that are greater than 4 and smaller than 6.66? We have only two natural numbers that are greater than 4 and smaller than 6.66. And the two natural numbers are 5 and 6. So we found out that DE equals to either 5 units or 6 units. And that is the answer to the question. Again, the answer to the question is that the size of DE, the size of this line segment DE, is equal either to 5 units or to 6 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the value of DE. We know that DE is a natural number. We also know that CA equals to 2 units, and we know that CB equals to 8 units, and we know that DE is parallel to AB, and we also know that point G is the centroid of triangle ABC. And what is the centroid of a triangle? Centroid is a point where the three medians intersect with each other. So at point G, the three medians of triangle ABC intersect with each other. Okay? And we want to find out the value of DE or the size of DE. Okay? We actually have used rule number 1 that relates to the centroid of any triangle. According to rule number 1, the centroid of a triangle divides the median in a ratio that equals to 2 to 1. So if we have triangle ABC that could be any triangle, and we know that AD is the median of triangle ABC, that is to say, the median AD bisects BC or divides BC, side BC, to 2 equal parts. That is to say, BD equals to DC. And we also know that point G is the centroid of triangle ABC. So according to rule number 1, the centroid G divides the median AD in a ratio that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Okay? According to rule number 1, if AG equals to 2 units, then GD equals to 1 unit. If AG equals to 2 units, then GD will be equal to 1 unit. Or in other words, AG is twice as large as GD, or AG equals to 2 times GD. Okay? So we can implement rule number 1 in our triangle, because in our triangle we have point G that is the centroid of triangle ABC, and according to rule number 1, the centroid G divides the median CF in a ratio that equals 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit. Okay, or in other words, CG is twice as large as GF. That is to say, CG equals to 2 times GF, according to rule number 1. And if we define CG as 2x, that is to say CG equals to 2x, then we will substitute CG by 2x because CG equals to 2x, and we will get that 2x equals to 2 times GF. Then we will divide this equality by 2 and we will get that GF equals to x. So we found out that if CG equals to 2x, then GF will be equal to x. Here, if CG equals to 2x, then GF will be equal to x. Okay? Then we also have rule number 2. Rule number 2 is true in any triangle. We can apply it in any triangle. If we have triangle ABC, that could be any triangle, and we know that line segment DE is parallel to BC, then according to rule number 2, AD over DB equals to AE over AC. Again, if we have triangle ABC, that could be any triangle. And in triangle ABC, we know that line segment DE is parallel to BC, then AD over DB will be equal to AE over EC. Okay, that is rule number 2, and we actually can implement rule number 2 in our triangle. Actually, we implemented rule number 2 on the green triangle, because on the green triangle we know that DE is parallel to AB, and according to rule number 2, if we relate to the green triangle to triangle CAF, CD over DA will be equal to CG over GF. Again, because of the fact that DE is parallel to BC, if we relate to the green triangle, triangle ACF, we know that CD over DA equals to CG over GF. But what is the value of CG? The value of CG is 2x. So we can write here that CG equals to 2x. And what is the value of GF? GF equals to x. So we can write here that GF equals to x. So in total we got that CD over DA equals to 2x over x. 2x over x is 2 because x over x is 1, so x will get cancelled. Then we will get that CD over DA equals to 2. And if we multiply this equality by DA, we will get that CD equals to 2 times DA. That is to say, CD is twice as large as DA. And if we define CD as 2y, that is to say CD equals to 2y, then we can substitute CD by 2y because CD equals to 2y. We'll get that 2y equals to 2 times DA. We will divide this equality by 2 and we will get that DA equals to y. So we actually found out that if CD equals to 2y, then DA will be equal to y. If CD equals to 2y, then DA will be equal to y. Okay, and then we actually have also rule number 3. Rule number 3 states that corresponding angles between parallel lines are equal to each other. Okay, so what is the meaning of rule number 3? Rule number 3 states that if we have two lines that are parallel to each other, then the corresponding angles in those two parallel lines, between those two parallel lines, will be equal to each other. And we can implement rule number 3 in our drawing, because we know that in our drawing that line D is parallel to line AB. Therefore, those two corresponding angles will be equal to each other, and if one of them is alpha, then the other one will be also equal to alpha. Okay, so angle CDE will be equal to angle CAB, and both angles will be equal to alpha according to rule number 3. Why? Because those two angles are located between parallel lines. That is to say, DE is parallel to AB, and those two angles are located between those two parallel lines. Therefore, they are equal to each other. So angle CDE equals to angle CAB equals to alpha according to rule number 3. And we can use the same rule in order to prove that those two angles are also equal to each other. Why? Because those two angles are located between the parallel lines DE and AB, therefore they will be equal to each other. Okay, according to rule number 3, angle CBA equals to angle CED, and both are equal to beta according to rule number 3. So we found out that those two angles are equal to each other, and they are both equal to alpha, and those two angles are also equal to each other, and they are both equal to beta, and they are equal to each other according to rule number 3. Okay, then we focused on the big triangle, triangle ABC, and on the small triangle, triangle CDE, and we proved that those two triangles similar to each other. So if we focus on triangle ABC and triangle CDE, we know that angle CAB equals to angle CDE, and those two angles are equal to alpha. Those two angles are both equal to alpha, and we also know that angle ABC equals to angle CED, and both are equal to beta. Those two angles are also equal to each other, and they are both equal to beta. And we also know that angle C is a common angle. It belongs both to triangle CDE, and angle C also belongs to triangle ABC. Therefore, we can write down that angle C equals to angle C is a common angle. So we actually proved that the three angles of triangle ABC are equal to the three angles of triangle CDE. Therefore, we proved that triangle ABC is similar to triangle CDE according to angle similarity rule. And what is angle similarity rule? Angle similarity rule is that if you prove that all the angles of one triangle are equal to all the angles of the corresponding angles of the other triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. Okay, so from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Again, because of the fact that the big triangle ABC is similar to the small triangle, triangle CDE, we can conclude that CD over CA equals to DE over AB. Okay, but what is the value of CD? CD equals to 2y. And what is the value of CA? CA equals to CD plus DA. So CD plus DA is 2y plus y. So in total we got that CD equals to 2y and CA equals to 2y plus y. Or 2y over 2y plus y, that is 3y, equals to DE over AB. 2y over 3y is 2 over 12 because y over y is 1. So y will get cancelled, and we left only with the equality that DE over AB equals to 2/3. Here we will multiply this equality by AB, and we will get that the value of DE is actually 2/3 AB. Again, DE equals to 2/3 AB. Then we have rule number 4, that states that the sum of two sides of any triangle is always greater than the length of the third side. That is to say, if we take any triangle, and triangle ABC can be any triangle, and we will do the sum of two sides of the triangle, then this sum will be always greater than the length of the third side. That is to say, AB will be always greater than C. That is the third part of rule number 4, that A plus B will be always greater than C. That is from one side. But from the other side, the difference of two sides of any triangle is always smaller than the length of the third side. So the difference of two sides of any triangle, so if we take A and B and we will do the difference between them, that is to say A minus B will be always smaller than the length of the third side, that is to say will be always smaller than C. Or in other words, C will be greater than the absolute value of A minus B. And what is the absolute value of any number? The absolute value of any number is the distance of the number from 0. Okay, so we have rule number 4, that we can describe it by this inequality, that C will be always greater than A plus B from one side, but C will be always C will be always smaller than A plus B from one side, but from the other side C will be always greater than the absolute value of A minus B. Okay? And again, we can implement rule number 4 in our triangle, triangle ABC. If we relate to side AB of triangle ABC, we can say that according to rule number 4, AB will be always greater than CA plus CB from one side, but AB will be always smaller than CA plus CB. AB will be always smaller than CA plus CB from one side, but from the other side, AB will be always greater than CA minus CB. Okay, AB will be always greater than the absolute value of CA minus CB. But we know that CA equals to 2 units, CB equals to 8 units. So CA minus CB is 2 minus 8. So we got here that 2 minus 8 is minus 6, and the absolute value of minus 6 is 6, because the absolute value of any number is the distance between the distance of this number from 0, and the distance of minus 6 from 0 is 6 units. So here we'll get 6, and here 2 plus 8 is 10. So in total we got that AB will be greater than 6 and smaller than 10. But we have already found out that DE equals to 2/3 AB. So if we multiply this inequality by 2, we will get that 2/3 AB equals to 2/3 times 6 and 2/3 times 10. 2/3 times 6 is 4, and 2/3 times 10 is 6.66. And 2/3 times AB equals to DE according to this equality. So we can substitute the value of 2/3 AB by DE, and we will get that DE is greater than 4 and it is smaller than 6.66. But it is given us the question that DE is a natural number, it belongs to the natural numbers. So which natural numbers we have that are greater than 4 and that are smaller than 6.66? We have only two numbers. that are actually 5 and 6. So the value of DE will be either 5 units or 6 units. That is to say, the size of DE is either 5 units or 6 units, and that is the answer to the question. Okay, thank you very much.